Welcome. We're going to solve systems with conics. We're going to do inequalities with conics. Well, let's start with a review of the basic thing of a linear equation or a linear inequality. So I'm going to solve this one by using y equals mx plus b and then testing a point. So I'm going to subtract x, y greater than 1 minus x. Actually, that's negative x plus 1. Because if I do it this way, I have a slope here of negative 1 or negative 1 over 1, and I have a y-intercept of a positive 1. So I'm going to come over here first and graph that. And then the slope is a negative 1 going down 1, and then a positive 1. So I'll go to the right. And I can continue to do that a couple of times. Or I can do the opposite and make it as if it was, well, a positive 1 over a negative 1, which does the same thing, but it goes the other direction. Okay. Now, one thing I have to notice is that this is an inequality without an equal sign. That means the points on this are not acceptable answers, and we have to show that with a dashed line. Having done that, now you could also graph this with x and y intercepts or with an x and y table, but I prefer to do it in a y equals mx plus b form, so I did. That's step 1. Step 2 now is to test the point. If 0, 0 is available, meaning it's not on the line, then it's a good point to test, because you can go back to the original and you can put a 0 in for x plus a 0 in for y and see, is this true? Is 0 greater than 1? It is not. It is false. And because it is false, then you don't shade the side that has 0, 0, but rather you shade the other side. So this problem has three things, the three things in it that needs correct. The line is correct, the dashed part is correct, and the shading is correct. Let's now look at a conic. This one is a circle. It is in that form for a circle, which means that since there's no plus or minus after the x or y, it means that the center of the circle is 0, 0. And the radius of the circle is the square root of 4, which is 2, because 4 is the radius squared. Now, this one we notice is an inequality with a line under it, so it means the actual line of the circle counts as a solid line instead of a dashed line. I'm going to go out 2, so the radius is 2 in all directions, which means I have to curve around here to make it so it's still 2. Now we're going to test a point. So that was number 1, was to graph it with those things. Number 2, we're going to test a point. For you, okay, here's a little tip. Use the center for circle, ellipse, and hyperbola, because those will give you zeros on one side of it. So right now, x squared plus y squared is less than, let's go back to that, less than or equal to 4. I put a 0 here and a 0 here, a 0 less than or equal to 4. That is true. Therefore, we take this spot where it is 0, 0, and we shade there. The whole inside of it gets shaded instead of the outside. Now, the third one of this is where we're going to put them together. So notice this one was shaded this way, this one was shaded this way. Now a system is when we put them together. So I'm going to put the line, dashed line, and I'm going to put the circle, okay, which is here. I'll put arrows on the end of that line too. And this area had been shaded, and the inside of this was shaded. So the part where they are both shaded together is right here. There. I think I can get almost all of it. Okay. So a system is where you're going to graph the two of them and find the region where both are shaded at the same time. So this area is where all the solutions are. Let's look now at a different one. So in the first one, this one looks like a parabola. Blue, actually. The first one is a parabola. And the second one looks like it would be an ellipse. Because these numbers are different, it's an ellipse, well, with a plus. So we have a parabola and we have an ellipse. Where exactly are they? What they look like when shaded, that's what we're going to determine. So let's start with one of these. Okay. And down here is where we will do a graph of them. So I'm going to start here. The fact that we have the vertex is, this should be minus h here. But since there isn't anything, that means we have a 0 there. And we have a -3 for the k. That's h and k. Okay. Now, I see it's going to be a solid line, right? Well, actually, let's do first, we know where the vertex is. 0 and -3. There's a couple of ways to get parts of it. I could do the focus point and the lattice rectum. However, instead, what I'm going to do here is do an XY table. And let's do just a couple of points that would enable this to more easily be solved where it is. So let's start with putting the 0 and -3 here in the middle. And then if I go up 1 and up 2 and down 1 and down 2 from there, if I put 1 in here, I'll get a -2. If I put 2 in there, 2 squared is 4 minus 3, that gives me a 1. Same thing, if I put in the -1, I'm going to get -2. If I put in -2, I'm going to get a +1. So that's the second thing to do. Third thing is to recognize that we're going to have a solid line. Okay. So, well, I don't want to go quite that way. I want to go this way. So let's graph that down here. 1, -2. 1 and -2, and 2 and 1. -1 and -2, and -2 and 1. Now we have enough here to draw the approximate, and it is a solid line. Okay. Let's go through that line a little bit more. Whoa, sooner or later I'll get this one right too. Okay, so they're not perfect there, but I've gotten closer. Over here, because I want to have this graph go to the end of the approximate end there. Okay, so that's approximately what the parabola looks like. Now, I should not have done this quite so quickly, because then the fourth thing you need to do is test the point. Okay. Now, when I look at this, I see that 0, 0 is inside it very clearly, and that's always the easiest one to use. 0 for the y, less than or equal to 0 squared minus 3. Well, that's 0 less than or equal to, that goes away. 0 is not less than 3 or equal to it. All right, now I can blows off this part, and we'll use the rest of it for the other thing. But it tells me that the shading for that is going to be all on the outside here. So having done that, let's now figure out where the ellipse is. So the things I look for that to graph it, first is the center, which would be opposite signs, H, which is with the X, and K, which is with the Y, and you do the opposite sides for it. So that's the first thing that I do. So let's put that center down there, 3 and -1. I think I'll put that one in red here. 3 and -1. Okay. Now I need to go which way? I need to go right and left and up and down. Because the larger number is under the X, that means we're parallel to the X-axis. So the second thing, A is equal to the square root of 16, which is equal to 4. That means because we are going horizontal, parallel to the X-axis, we need to go 4 this way, 1, 2, 3, 4, 3 and 4, and 4 the other way, 1, 2, 3, and 4. And then we need to go up. Third thing, the B is the square root of 4. This is B squared, this one was A squared, which is equal to 2. So this one we went sideways, 4 each. This time we're going to go up and down 2 each. So up 2, down 2. I don't really need to put points there. Sometimes they're called co-vertices, but that's not really that important and really aren't vertices in my opinion. So this is enough to graph this. Oh, I need to determine solid line or not. So what I see here means a dashed line. Dashed line. And I'll do that with number 4 here. So let's dash that. Okay. Reasonably close to do that. Some of that over. Okay. Reasonably close to an ellipse, like it should be. Well, now we have to test a point, and because the center of the ellipse will cause some zeros in the problem, it will allow us to more easily determine if we should shade where the center is or the other part of it, or outside of it. So 5, test a point. Let's break that more. Test a point. Use the center. So what we'll do with that is we'll take this whole thing. And so the center is 3, -1. So I do 3 minus 3 squared over 16. I'm following what I see up there. And -1 plus 1 squared over 4. Is that less than 1? Well, this is 0 over 16, which is 0, and 0 over 4, which is 0. So 0 plus 0 is 0. So what we have is 0 less than 1, which is true. And because that's true, that means the area that is inside gets shaded. And that happens to match the outside of the parabola. But part of the ellipse, okay, part of the ellipse is not shaded because it's on the inside of the parabola. So I'm being careful here. Well, some of it's going away as I'm doing it, but I'm trying to be careful to stay. Okay, I think that's enough to show that I've shaded well, and that I mean to shade on the inside there, but not here, right, and not out here, out here. So that's important to see. Those are not places to shade. And now that's how this one's done. We had to graph 2 things. We had to graph this parabola, we had to graph this ellipse correctly, and then figure out that the area inside here was the place where both of them were shaded together. So this is what you have to do in solving a system of conics. And you could have any combination with these. Just as a quick thought, we could have something like a hyperbola with an ellipse here, and it would be the inside of the ellipse and the outside of the or the inside of both of the outside, I guess. So it could be this part that was shaded, or it could be the outside here, and actually it would be and the outside of the ellipse. So the outside ellipse and the outside of the hyperbola, and that would count for all of that area. So that would be where they match. Or if it was the inside of the hyperbola, no, the inside of the, let's think about, the outside of the ellipse, but the inside of the hyperbola like this. I don't know whether you call it the inside or the outside, but it could be like that too. So it just depends on the greater than or equal signs and then where they're shaded. Okay. So those are other possibilities, other things. Anyway, in this case here, you'll see now how you graph one, graph the other, figure out where they're shaded together in the same spot. I hope that helps with seeing how this kind of a problem is done. So thank you for watching and listening.